Alright, so this is all the information. This 64 here, CE 36, 90, and the first question was to find CD, the length of CD. Okay? So if you think about it, if you look at CD, you can say, well, I know these two lines are parallel. So I know CD over 90 must be equal to 64 over 36. Okay. We can say that. We can say CD over 90 is equal to 64 over 36. So we can solve that one. Okay, so when we cross multiply CD times 36, 90 times 64, we get here. And then we divide both sides by 36. Divide by 36, divide by 36. So CD is going to be 160. Okay, so we can put in 160 here. We got that. And the reason is proportional theorem, because DE is parallel to AF. So, okay, if we know that BD is 120, and this is 90 degrees, then we can use Pythagoras to find FB, because that's the next one we need, is FB. Okay, so we can say BC, C squared, the long side squared, is equal to 160 squared plus 120 squared. Okay, from Pythagoras. Okay, so we can say this. Okay, and then we can find this whole side BC, and then we can subtract 120. So we can say therefore BC squared is equal to, then we can check that one. Okay, so BC squared is 40,000, which means the square root is 200. So if BC is 200, we can subtract 100 to find BF. So we can say therefore that BF is equal to 100. Okay, 200 minus 100. So we found BF. Okay, so we can put that BF is equal to 100. Okay. Okay, so the next one we want is AF. Okay, but we're first going to need AB. So we're going to say AB squared is equal to the 120 squared plus the 90 squared. So we're going to use Pythagoras again. 120 squared plus 90 squared. Okay, in this triangle. So we use Pythagoras. And then we can get AB squared. Okay, we can check that one and then find AB. Alright, so we quickly finish this one. We got AB is 150. And then we used AB and FB. 150 squared plus 100 squared to find AF squared. Then if you simplify, you get AF is 180,28. So we got AF as well. Okay, and we got AB 150 over here. And that one. Okay, so the next one. Okay, so now we finally get to a question that's actually not just Pythagoras or basics. Now it's a little bit more work. So now they want you to find DE. Okay, we need to find the length. Now we know that FA is 180,28. And we need to find DE. Okay? So you're going to think now, a question like this might count like 5 marks. Okay? Because what you want to do is you want to say DE over FA is equal to CE over EF. That's what you want to say. Okay? Or, no. If you look at this triangle, this one over this one, DE over FA, you want to say it's equal to 64 over CF, the whole side. Because if I can show that this triangle here is similar to this bigger triangle, if they're similar, then the smaller side over the bigger side must be equal to the smaller side over the bigger side. That's the important thing. So before we can just say DE over FA is equal to CE over CF, smaller over bigger equal to smaller over bigger. Before we can say that, we first have to prove that these two triangles are similar. So many times they ask the two questions separately. Many times they first ask you, prove that CED, okay? Prove that triangle CED is similar to CFA. Okay, so we're going to say in triangle CED and triangle CFA, we can say that C is a common angle. We can say that CED is equal to CFA. Okay, it's corresponding angles because ED is parallel to FA. And then we can obviously say the third angle is equal. So CDE is equal to CAF. Okay, third angle, triangle. Okay, or interior angles of triangle. Okay, therefore, triangle CED is similar to triangle CFA. Angle, angle, angle. And now we can say, therefore, because we showed they're similar, now we can say that CE over CF, 64 over 100, must be equal to DE over 180,28. Now we can say that. Okay. The important thing is you take the smaller triangle side over the same triangle side on this side, but the bigger one. 64 over 100 is equal to DE over 180,28. Now we can quickly solve that one. Okay, so when you cross multiply here, you can find that DE is 105,38. So we found this one. And the reason why we can put the ratios equal between the smaller triangle and the bigger one is because we showed the triangles are similar. That's why we can put the smaller triangle over the bigger triangle for the sides.